here to talk about security. I was wondering how many of you have heard about an expression called turtles all the way down. Just a show of hands. Okay, good, a few. This is an expression that often refers to security in depth. And it's reasonable because if you think about a turtle, it has a hard shell, and a stack of turtles could be a metaphor for layered security. However, the Trusted Computing group has a different interpretation of this phrase. It is actually inspired by a child's story called Yertle the Turtle. In the story, Yertle conscripts his fellow turtles to build a stack underneath him, and he raises his throne ever higher into the sky. But the bottom turtle, his name was Mac, and Mac burped and caused the stack to fall into the mud, after which Yertle became known as the king of the mud. This is useful for security practitioners because it teaches us to be humble, because things can break. Now, the TCG used this analogy to reason about roots of trust. They wanted to know what functionality made sense to put in this bottom turtle. And so they came up with 3 classes of functionality: measurement, and a root of trust for measurement, storage, and reporting. Now, the storage and reporting components were combined into something called a trusted platform module. Many of you have a trusted platform module in your PCs today. They're shipped everywhere. The root of trust for measurement, however, wasn't standardized, and that ended up as vendor-specific solutions, such as Intel's trusted execution technology. Now, the question still remains in the TCG: what if these roots of trust could be decomposed even further? And the prospect of doing that became known as turtles all the way down. That is something to think about. Fast forward to the Internet of Things, where a new class of security challenges emerges. And so we need solutions for these kinds of problems. And so one possible solution is to take a TPM and integrate it with an IoT device and solve the problem that way. However, if you're familiar with the TPM, the real estate of a TPM often is larger than the IoT device itself. So the economics of IoT simply don't allow for traditional roots of trust to be used as the bottom turtle. So recently, the TCG came up with a new solution, which is a root of trust aimed at Internet of Things. They call this Device Identity Composition Engine, or DICE. DICE consists of some very basic ingredients. There's a physically unclonable function, and then a hash of the device firmware that's combined into something called a pseudo-random function, such as HMAC, and the result of that produces something called a compound device identifier. That value can be fed into a key generation function to generate what's called an attestable device ID. Now, the interesting thing about a testable device ID is that the keys are regenerated at power reset, so you can always return the device to a secure state. Additionally, if the signing operations will also double as attestation, because the device firmware is tied to the signing operation. So if the firmware is modified, then the use of the key can detect that the firmware has been modified. Now, a second layer, this technology allows for layering, and a second layer, a turtle, if you will, can be constructed using largely the same ingredients, only the puff value is replaced with the CDI from the previous layer. So in theory, there's no limit to the number of layers that can be constructed. So essentially, this is turtles all the way up. Now, DICE, however, is not limited to IoT. Intel's SGX technology implements DICE functionality and adds to it local attestation. There are other places where this DICE technology can be applied. For example, virtualization, PC peripherals, containers, rack scale, and even decentralized computing. Decentralized computing is really interesting because a coalition of computers works together to establish consensus. However, if the majority of the computers are compromised, then consensus actually benefits the attacker. So something called a decentralized trusted computing base can be used to mitigate these attacks, this is done by using attestation as a way to control the formation of the coalition. So if you put these ingredients together, essentially dice for root of trust for your devices that then use peer-to-peer attestation, you can think of this as essentially a bale of turtles. And I think that analogy may be useful for informing and thinking about this idea of trusted decentralized computing. Thank you.